Hello everyone. I, Mrs. Vineeta Philip, Assistant Professor in Department of Electronics and Telecommunication Engineering of AISSMS, Institute of Information Technology, Pune, welcome you all for my series of videos pertaining to important topics of the subject Signals and System for SE E&Tc Engineering 2019 pattern. In this video, I would be discussing on the topic convolution. What is convolution? It is a mathematical operation on two functions to produce a third function that expresses how the shape of the first is modified by the other. There are two types of convolution. One that is calculated for CT signal is known as convolution integral, and the other that is calculated for DT signal is called convolution sum. In this video, I would be discussing convolution integral for signal combinations wherein both the signals are unit step, and for the case when one of the signal is unit step and the other is an exponential signal. The formula for computing convolution integral is as seen. The procedure involved are: first we need to time reverse any one of the signal. Then shift that signal to the right by t amount of time. The two signals need to be multiplied and finally integrated in the overlapping time interval. So moving on to our first case wherein both our signals are unit step signal. Let us see how to compute the convolution integral by graphical method. So first we will sketch both the signals and change the time axis to tau. After this, we will reverse one of the signal. This time reverse signal is then shifted on the time axis. As we see here, there is no overlapping for t less than or equal to 0. So we get the resultant y of t is equal to 0 for t less than or equal to 0. In case 2, we shift the time reverse signal towards the positive x-axis and we get an overlapping region in the range between 0 to t. Integrating in this overlapping region for the overlapping time limits, that is y of t is equal to integration 0 to t 1 into d tau. Here 1 is nothing but the amplitude of our signals. So the resultant answer of integration is tau. Substituting upper limit minus lower limit, we get y of t is equal to t. We know that this mathematical expression is of the ramp signal. So here is a sketch of our output signal y of t is equal to r of t. Now let us proceed to the next case where one of our signal is unit step signal and the other is an exponential signal. These signals are first sketched and the time axis is changed to tau. After this, we will reverse one of the signal. So here let us reverse x1 of t, which is u of tau. We see that for case 1, when t is less than or equal to 0, the two signals do not overlap. Hence, y of t is 0. Now, if we shift the signal towards the positive x-axis, we get an overlapping region between 0 to t. So y of t is integration 0 to t e raised to minus a tau d tau. The resultant integration is e raised to minus a tau upon minus a. Substituting upper limit minus lower limit, we get y of t equal to 1 by a into minus e raised to minus at plus 1. Rearranging the terms, we get y of t is equal to 1 by a into 1 minus e raised to minus at for t greater than 0. Let us sketch this output signal. So the sketch of the resultant output signal is as seen. That's all for now. Thank you for watching. Stay tuned for many such videos on important concepts of signals and systems. Thank you.